In this video, we're going to be discussing electron configuration. Now, to do electron configuration, we do have to outline our periodic table in this fashion, okay? Which the first two columns are what we're going to call the S block. The next 10 columns are called the D block. The next 6 columns are going to be called the P block. And down here at the bottom, this is going to be the F block. Now, what we've learned in previous lessons is how to calculate protons, electrons, and neutrons using the atomic number and the atomic mass. And from that, we know that the protons and neutrons go into the nucleus and that the electrons are going to be in orbits around the nucleus. And what electron configuration tells us is how many electrons are going to be on each of those orbits in a Bohr model. So today's lesson is going to conclude with a Bohr model where we do everything from calculating the protons, electrons, and neutrons to writing out the electron configuration, which is the lesson in this particular video. And then we're going to put those two things together to draw a Bohr model. Okay, so let's go ahead and get started. What I'm going to do is I'm going to start at the very beginning and we're going to do some elements at the top of the periodic table. Then we'll do a couple in the middle of the periodic table, and then we'll do a couple at the bottom of the periodic table. But before we get started, we've already identified our blocks, but we see that helium is kind of like outside of this P block. For electron configuration, we're going to move helium right over here, and we're going to pretend that it's in the part of the S block in this missing portion right here. Now, most of the time, helium belongs with the noble gases over here, but for electron configuration, helium is actually better placed on the periodic table over here. But that's just one out of the many, many concepts that we have in chemistry. So most of the time, it kind of belongs over here with a couple of exceptions, and today's lesson is one of those exceptions, okay? The other thing I'm going to do is I'm going to number the side of the periodic table. And I'm going to do that with row numbers. And I'm going to stop here at 7 because I want you to recognize that if we look down here at the F block, we have atomic numbers 58 through 71 right here. And they actually fit right here because this jumps from 57 to 72. Well, this whole first row is actually inserted in between 57 and 72. So if that is part of row 6, this is actually part of row 6 as well. Same thing for here, 90 through 103 gets placed right here, so that's actually part of row 7. Now, the best way to teach electron configuration is through examples. And this is kind of like a lesson where you have to establish a pattern. So I'm just gonna go ahead and get started by doing a couple examples, and I think you'll see how the pattern will emerge, okay? So I'm gonna write down my electron configuration on this piece of white paper, and then I'm gonna use this periodic table as a resource, okay? So the first thing I'm gonna do is I'm gonna do kind of like an easy one here. We're gonna do lithium. And if you calculate protons, electrons, and neutrons, you're gonna find out that lithium has 3 protons. If it's neutral, it's also gonna have 3 electrons. And when I do electron configuration, I'm gonna start up here at the top of the periodic table, and I'm gonna keep going until I get to the element or the number of electrons that I'm trying to get to. So in this case, it's going to be lithium that I'm trying to get to. And if I start up here in the upper left-hand corner, the row is 1. I'm going into the S block, and I'm gonna go all the way through it. So that's 1, 2. So I've gone through 2 blocks, and that's going to be the exponent. So the electron configuration for lithium starts out with 1s2. In fact, all electron configurations are going to start out with 1s2 as long as there's more than 2 electrons in that particular structure. Now, we're trying to go to lithium, so after we go through the first row, we're now going to enter the second row. So we're going to write down a 2. We're still in the S block. But instead of going all the way through it, we're going to stop here at lithium. So we're going to stop in the first block. So we call that 1s2, 2s1 for lithium. And if you'll see, anything that's larger than lithium, that electron configuration will start out similar, and then we'll add on. So let's do something like nitrogen. Nitrogen's a little bit bigger, so the next problem that we're going to do is going to be nitrogen. Same concept as before. We always start in the upper left-hand corner, and we're going to travel through the periodic table until we get to the nitrogen or 7 electrons, okay? So we're going to start out with 1s2 because we're in the first row, and we go all the way through it, and there's 2 blocks there, so 1s2. We're going to go through the whole second part of the s block, so it's going to be 2, it's going to be s, and since we go through the whole thing, 1, 2, we went through 2 blocks, so it's going to start out with 1s2, 2s2. Now we're not at nitrogen yet, so you got to keep on going in the second row, so it's going to be 2, but now we're entering the p block, so it's going to be 2p. We're not going to go through the entire p block because nitrogen is right here, so we're going to go over 1, 2, 3, and that will be your exponent. So 1s2, 2s2, 2p3. So those are kind of like the 2 easy ones. Let's go into kind of like 2 medium ones, okay? Let's do something like sodium right here. We'll go to sodium. So same thing, we're starting the upper left-hand corner. We're gonna go all the way through the first row, so it's gonna be 1s, and we go through both of them, so it's gonna be 1s2. And we're gonna go through this whole second row, okay? So it's gonna be 2s2, and you keep going along, second row, p block, and we're gonna go through all of it. So it's gonna be 2p, 1, 2, 3, 4, 5, 6. It's gonna be 2p6 to get all the way through. Now remember, we're going to sodium, so we're gonna stop right here, which is in the third row. So we're gonna write down 3. It's in the s block, so we're gonna write down s, but we're gonna stop right here, so it's just going to be 3s1. Let's say we want to do something like, we'll do chlorine here. So we want to stop in the middle. So for doing chlorine, I'm going to start with the row number 1. We're going to go all the way through. So it's 1s2, and you can see all of these begin with 1s2 if there's more than 2 electrons, okay? But we're going to go all the way to chlorine, which has 17 electrons. So it's going to be 2s2, 2p6, 3s2, and if we're stopping at chlorine, we're not going all the way through, but we're in the third row, p block, so it's going to be 3p, 1, 2, 3, 4, 5. It's going to be 3p5. And that's how you do kind of electron configuration for kind of like those medium-sized problems, okay? Now, we haven't gone into the D block yet, okay? And the D block does get tricky. There is a rule that says that D block electrons are not valence electrons. And since they're not valence electrons, we got to subtract 1 from the row number. So this might be the 4s section of the periodic table, but this is not 4D. This is actually, we got to subtract 1. This is actually going to be 3D. So remember, whenever you go into the D block, you have to subtract 1 from the row number. And it even gets a little more crazier when you get to the F block. If you ever get to the F block, you would have to subtract 2. So this is not the 6F section. If I have to subtract 2, this would be the 4F section, okay? So let's try to do one of these problems where we go into the D block and then we come out of the D block. Maybe an element like arsenic. Let's do arsenic next. So if we have arsenic, As, and it has 33 protons and 33 electrons if it's neutral, we're going to start in the upper left-hand corner. We're going to go through the periodic table, and then we're going to stop at arsenic. So it's going to start out with 1s2 again because we're going to go through the whole first row. 1s all the way through will be 1s2. We're going to go through the 2s2 part. Keep going. Second row, P block. So this is going to be 2p6 to get this far. Followed by 3s2. And after 3s2, it's going to be 3p6. Followed by 4s2. Remember, this is where it gets tricky. I'm going into the D block. So this is not 4D. We got to subtract 1 from the row number, so it's going to be 3D. If we go all the way through it, that's going to be 3D10. And it's very important that we subtracted 1 from the row number when in the D block. Now, when you're in the S or the P, you just use the row number. So right here, I'm now in the P block, so I'm going to use the row number, so it goes back to 4P, and if I'm going to arsenic, 1, 2, 3, it's going to stop at 4P3. Okay, let's try one more of these bigger ones where we go through the periodic table. Let's do a really, really big one. Let's go all the way up to barium. And if we go to barium, okay, we gotta go through kind of quite a bit. So I'm actually gonna start a new piece of paper here for barium so I can put it at the top up here so you can see it in the frame, okay? So here we go. We're gonna start out at the very top. It's gonna be 1s2. Going through the second row, it's gonna be 2s2. Then it's gonna be 2p6. 3s2, 3p6, 4s2. Now be careful, we gotta subtract 1 because we're going in D block. 3d10. Coming out of the D block, we're back in the P block. P block, you do not subtract 1. So this is going to be the 4P, and I'm going to go all the way through it. So it's going to be 4P6, 5s2, back into the D block, so we got to subtract 1 from the row number, so this is going to be 4D10. In the P block, so I use the row number, so it's going to be 5P6, followed by 6s2. And we're stopping here because barium has 56 protons and 56 electrons. So that's how you deal with electron configuration, okay? Just remember, if we ever went into this F block, we would have to subtract 2. Because it's the F block, we subtract 1 from the D block. And for the S and P, we don't subtract anything. So if we ever went in past barium, after the 6s section, you'd come down here, and this would be the 4F section. This would be 5D. This would be 6P, 7S, 5F, 6D, and if you kept on going, it would be 7P. This is kind of an older periodic table. I think the current periodic tables have this row already finished, okay? Now, I do want to put all this stuff together in how to make a Bohr model. So if we came back here and we were looking at arsenic, and we were looking at its electron configuration, and we're going to combine that with knowing some information about arsenic. I'm going to pull off 74.9. I'm going to round that to 75. And of course, the atomic number is going to be 33. So we did this from a previous lesson. So if you need to know this information, how to calculate protons, electrons, and neutrons, it's in one of my previous videos. But the atomic number is 33, and that tells you the number of protons. There's no charge, so the electrons are 33. And of course, the neutrons is the mass of the protons and neutrons added together. So what number plus 33 will give you 75. I believe that number is 42 because 33 and 42 will give you 75. So with this information about arsenic, as well as its electron configuration, we can take both those pieces and put together to make a Bohr model. The nucleus is very small, so I always identify that as a tiny dot, and I'm going to label it with the protons and the neutrons. They would go in the center, so 33 protons and 42 neutrons would be in the center. And then these electrons, these 33 electrons, are put in different orbits and layers, okay? So if we were going to do that, the electron configuration is actually the code that tells us how many electrons go on each ring. These big numbers in front tell you which ring it's on. And then the exponents tell you how many electrons are on that ring. So if we look at this part, there's only one thing that has a 1. So on the first ring, if we look at this exponent, there are 2 electrons on that first ring. Now some science teachers make you do little dots for each electron. I'm not doing that. We have 33 electrons. We're just going to put the number right on the ring, okay? So let's take a look at the code and see what's on the second ring. The second ring has the 2s and the 2p, so I'm going to underline both of those. And if we look at those exponents of 2 and 6 that are on the 2 ring, that means that there's a total of 8 electrons because these exponents of 2 and 6 are going to equal 8. Okay, so there's 8 electrons on these 2 rings. Now be very careful here. Ring number 3, okay? Ring number 3 has the 3s and the 3p and the 3d. Okay, so I'm going to kind of block those in. The 3s, the 3p, and the 3d. And if we add up those electrons, 10 plus 6 plus 2, there's 18 electrons on that third ring. And then lastly, the fourth ring is going to have 2 plus 3 is going to have 5 electrons. And we know that those electrons on the outermost are called valence electrons. And the number of valence electrons an atom has will be very, very important when it comes to bonding, okay? It really defines the behavior of these elements. And if for some reason we did not subtract 1 from the D block, and this was actually 4d10, we would have put those 10 electrons in the valence shell, and they don't belong there. So once again, the reason why we subtract 1 from the row number is because these D block electrons, they're not valence, okay? And the vocabulary word that we give for the other electrons that are not valence, we tend to call them core electrons. So D block electrons, they're part of the core electrons. They are not part of the valence electrons. And if we were going back to look at barium very quickly, okay? This is a massive atom, okay? Barium has a mass of 137 and atomic number of 56, okay? So if we were looking at calculating the protons, electrons, and neutrons for this, the protons would be 56. And since there's no charge, the electrons would be 56. And then the neutrons would be the rest of the mass. Okay, so if I take 137 for the total mass and 56 of it comes from the protons, then the other 81 has to come from the neutrons. So barium's going to have 56 protons and 81 neutrons, which gives us a total mass of 137. Now let's put that together in a Bohr model. Tiny dot for the nucleus, 56 protons and 81 neutrons that I just calculated. Now let's put this code together to figure out what the rings are. We got the first ring that has 2 electrons. We got the second ring that has 8 electrons. We got the third ring that has 18 electrons. We got the fourth ring, which has the 4s, the 4p, and the 4d, which also has 18 electrons. The 5s and the 5p is going to be 8 electrons. And then finally on the sixth ring, we have the 6s2, which means that there's only going to be 2 valence electrons for barium. And that kind of makes sense according to the periodic table. I hope that helps you do electron configuration and build Bohr models.